In this video, we're going to be looking at a lesson called Solving Quadratic Equations, which falls under Unit 3 for the Algebra 2 with Statistics. So looking at the big picture, we can see that in yellow, if we scroll down week 6, this is actually a 2-day lesson, so that's why it's in 2 boxes here. So this is actually going to be on days 3 and 4 for this unit. If we look at the big picture, it has all of the lessons, but looking at the scope and sequence is going to tell us a little bit more detail. And this is going to cover standard 6 and standard 10. So we're going to be looking at quadratics specifically and some polynomials, and we're going to be solving using different techniques. So the lesson actually is a bit of a review from Algebra 1. So it says that students should be familiar with completing the square, factoring, and using the quadratic formula. One of the ways that we're going to factor is by grouping. So if we go down and look at a warm-up question, the purpose of the warm-up is to really just illustrate the zero product property, which says that if I plug in a value for x that makes the first factor 0 by the zero product property, the product is 0. So if we set x minus 3 equal to 0 and solve by adding 3, we would get x equals 3. And we could also do that for the second factor, which is x plus 1. So to solve x plus 1 separately, we would subtract and get x equals negative 1. So 2 different factors gives us 2 separate solutions. Now, looking at the lesson on solving quadratic equations, this is an Engage New York lesson, and I'm going to go through examples 1 and 2 with you. So when we look at example 1, we can see that this is actually a factored polynomial, and each factor is quadratic. So what I'd like to do is solve the first factor using completing the square. And a couple things that help me decide that is the value of x squared, or the coefficient of x squared is 1. And also the middle coefficient, negative 6, is an even number, so it's easily divisible by 2. So what I want to do for setting each factor to 0 here is I want to actually leave a little bit of room, and I still have a plus 3 and set that equal to 0. So to complete the square, I'm going to take the negative 6 and I'm going to half that. And then I actually need to square that number. So that's going to give me negative 3 quantity squared, which is 9. And if I add 9 to the left side, I actually have to subtract 9 as well. So I still want this to be 0 and not change the problem. So the idea here is that I would now factor x squared minus 6x plus 9, because by completing the square, I've made that a perfect square. So when I factor that, I'm going to get x minus 3 squared, and 3 minus 9 is going to give me negative 6. So I still want to solve the entire quadratic, so I need to add 6 to both sides. I need to square root to undo the square on the left. And that's going to give me 2 answers on the right, plus or minus root 6. Now adding 3 to both sides would give me x equals 3 plus or minus root 6. So that would be 2 unique solutions. Now when I look at the second factor, which is 2x squared minus 4x minus 7, I'm going to use quadratic formula for this. A couple of reasons is because I have a leading coefficient that is not 1. So I'm going to look at the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And if I look at my standard form ax squared plus bx plus c equals 0, I'm going to see that a is actually equal to positive 2, b is negative 4, and c is negative 7. So we would just need to plug those in. So we would have negative 4 for the b, negative 4 quantity squared, minus 4 times a times c. And all of that is going to be divided by 2a. So a little bit of simplifying, we're going to end up with the square root of 16 plus 56. And that would give me 16 plus 56 is 72. and I need to determine the factors for 72. So this can factor down into 8 times 9, and this is actually going to be 2 times 2 times 2. And then 9 can break down into 3 times 3. So for square rooting, I need to take out my pairs. And so that's going to give me 2 times 3 is 6. And I'm going to have a root 2 left over right here. Okay, the only other thing that you might be able to do is to reduce the 4, the 6, and 4 if they have a common factor, which they do. They can all reduce by a factor of 2. And so reducing each one is going to give me 2 plus or minus 3 root 2, all divided by 2. One possible step that you could do is to break that up into 2 separate terms. And then we could reduce this to be a 1. So if I write my final answers from the first factor, I have 3 plus or minus root 6. And from the second factor, I now have 1 plus or minus 3 root 2 over 2. Now, if I take a look at example 2, it's going to be a polynomial that is actually a third degree, so it's cubed. And so this is not a quadratic equation, but we do want to solve by factoring. So the method we're going to use is factor by grouping. And the idea is that if I can take pairs of terms and find a greatest common factor, if those terms have a second greatest common factor, then I can factor completely. So if I look at the first two terms, x squared plus 3x squared, x cubed plus 3x squared, we have a greatest common factor of x squared. So if I factor out an x squared, I would still have an x plus 3 from the two terms. And if I look at negative 9x minus 27, they actually have a negative 9 as a GCF. So if I factor out a negative 9 from each term, I will have an x plus 3 left over in parentheses. So what's great about this is now when I look at the two terms that I have now created, they both have an x plus 3. So they have another greatest common factor. So I need to factor out that GCF. And I would be left with x squared and left with minus 9. Okay, so since we want to factor completely before solving, I can recognize x squared minus 9 as a quadratic, but it's a difference of two squares. So I still have my first factor x plus 3, and now I can factor x squared minus 9 into x plus 3 times x minus 3. And so now we can use the zero product property to set each factor to 0. I've got duplicate factors here. So if I set x plus 3 equal to 0, I'm going to get x equals negative 3. And that's going to end up being a double root. And I have x minus 3 equals 0. For the last factor, solving that by adding 3, I get x equals 3. So we still have 3 roots because it's third degree, but we have a double root at x equals negative 3. Now it's your turn. If you'll go back to page 1 and work through exercise 1 and then come back to exercise 2, then you can do the problem set and then post your assigned problem to the Google slide.